Okay, Assalamualaikum and a very good evening. Thank you everyone for joining the replacement class online tonight. So as mentioned in the class this morning, so we will continue with a few more tutorial questions tonight. So we have been doing so far the problems related to work and energy topic. And in the last example this morning, I have shown an example that involves spring. So tonight we will continue a few more examples, maybe 2 or 3 examples with problems that involve spring. And by the end of tonight's replacement class, we will finish with the first subtopic of chapter 3, which is the work and energy. So on Wednesday, we will continue our class with the last subtopic, which is the impulse and momentum. Okay, so let's look at this question 18.10. So it is basically almost the same like what we did this morning. 30 kilogram rod is released from rest when theta is equal to 0. So if you look here, theta is over here. So basically when theta equals to 0, it means that the rod is in this position. Okay, so this is basically the position of the rod when theta is equal to 0. So that is what we're gonna draw first. Okay, so we will draw that. So let's draw a line like this to indicate that this is the first position of the rod. Okay, so in this position, basically the spring will be something like this. This will be the spring. Sorry, let's draw that. Okay, so that this will be how the spring look like in the first position. So basically, this is our position number 1, and then it is released from rest. And what we want is to determine the angular velocity. Okay, angular velocity when theta is equal to 90 degrees. So now the rod has gone here. Okay, 90 degrees, meaning that the rod has gone there. And what happens to the spring is basically it is going to have an elongation like this. Okay, so this is our second position lah. Okay, so that is what we do first. When we read the question, you should visualize the initial position as well as the final position of the object. Okay, and there is another clue here. It says the spring is unstretched when theta equals to 0. So meaning that at position number 1, this is the original length of the spring. Okay. And then the next step is we need to draw the free body diagram. So basically the center of gravity, the midpoint is somewhere here. This is point G. So at point G is has basically traveled down to this point lah. So point G at position 1 and point G at position number 2. So basically at position 1, we will have mg pointing downwards like this. This will be mg. At position number 2, mg will be pointing downwards from here. So this will be the weight at position 2. So you can see that there is a change of height lah going on here, meaning that there will be work done by the weight. Okay, so we can here determine the delta y, which travels down in this direction. This is delta y. Okay, delta y is basically equal to half of the length of the rod lah. So basically here delta y is equal to negative 0.75. Okay, negative 0.75. Why negative is because delta y is pointing downwards. It starts from top to bottom, so delta y will become negative. So that is the first work done that we're going to calculate. So first we will calculate UW. Okay, so UW is basically equal to minus W times delta Y. So minus W, we have here 30 kg rod. So basically you have minus 30 times 9.81 multiply with minus 0.75. Okay, so you have two negative here, and therefore it will cancel out. So you will get UW is equal to positive 220.773 lah, 220.725 or 220.73 joule. So this is our first work done, which is 220.73 joule. Okay, the second work done here that we can see is the spring lah. The spring, so you can see the spring originally has this length at position 1, and at position 2 the spring has elongated. Okay, the spring has elongated. Okay, so we will write the spring work done by spring, which is the formula US is equal to negative 1/2 multiply with K. K here is given as 80 Newton per meter. Okay, so we have the value for K here. And then multiply with S2 square minus S1 square. Okay, so first we need to determine what is the value of S2 and S1 lah. Okay, so it says here the spring is unstretched when theta equals to 0, meaning that at position 1 the spring has the original length. Therefore we know that S1 is equal to 0 lah. There is no elongation. Remember, spring S is not the length ataupun bukan panjang spring tersebut, tetapi pemanjangan spring. It is not the length of spring, but is the elongation of the spring. So at position 1, the spring has not elongated. The spring has its original length. So S1 equals to 0. But we need to know the length. So meaning that the original length, L, I would write as L original of the spring. So how do we know the original length of the spring? We can see here that the total length is given as 2 meter from O to the end here. And we know the length of the rod is 1.5. So basically from here to here is 1.5 meter. So therefore you will get this length of the spring as 0.5 meter. So 0.5 meter will be the original length of the spring. So we will write here the original length is 0.5 meter. So we need this original length to calculate the S2. Okay, so to calculate S2, we need to find this length here. So we need to visualize this triangle. If you can see this triangle here, okay, you can see that triangle. Okay, I will zoom in. So this is the triangle. So this is the hypotenuse of this triangle. So basically, we need to calculate this hypotenuse H. Okay, we need to calculate this hypotenuse H. And then when we get this hypotenuse H, we will then subtract minus with 0.5 meter, which is the original length of the spring, so that we will get what is S2. So we have the length of the top here as 2 meter, and the length of this rod here 1.5 meter. So we have all the length. So basically we can then find the value of H lah. Okay, so if I can draw the triangle here, so we have like this. That is basically the triangle. So this is H, the hypotenuse. This is 2 meter and this is 1.5 meter. Okay, so we can get therefore the value of H is equal to 2 square plus 1.5 square using the theorem Pythagoras. And you square root this, you will get the value of H is equal to 2.5 meter. H is 2.5 meter, but this 2.5 meter is not S2. Remember, S2 is the elongation of the spring, so we need to subtract with the original length of 0.5. So S2 is basically equal to 2.5 minus 0.5. So S2 is basically equal to 2 meter. Okay, that is the value of S2. Okay, so then we will substitute in the US equation. So we have minus 1 over 2 multiplied with 80. K is 80 Newton per meter. And then we have S2 square, which is 2.5 square minus S1 is 0. Okay, so US here, we will get the value of equal to minus 160 joule. Okay, 160 joule. So this is our US lah, work done by the spring. Okay. So next, we have the work done. We will then go to the calculation of kinetic energy. Okay, it says here the rod is released from rest. Okay, so we know that it says released from rest. Okay, from rest. So therefore, we know T1 is equal to 0. Okay, very important for you to write down. T1 is equal to 0 because this will give you mark, and I need to know that you know T1 is equal to 0. Okay, do not assume that if you do not write the value of T1 equals to 0, I will give you mark, because if you do not write, then I cannot give you any mark lah in the test. Okay, so that is the initial kinetic energy T1. And then we will calculate also T2. This is a rotation problem, and you can see there is a rotation about the fixed point O. So basically, this is the fixed point O. So as I have shown in the class today, I prefer that you use the equation 1 over 2 IO omega 2 square. Okay, omega 2 square. So then what we need to find here is IO. So to find IO, first we need to calculate IG first. So this is a rod or a slender rod. You can refer to the table that I gave you in the previous class. So IG for slender rod is basically 1 over 12 ml square. Okay, so we have here 1 over 12. M is 30 kg and L is 1.5 square. Therefore, we got IG is equal to 5.625. Okay, IG is equal to 5.625 kilogram meter square. Okay, we have the value of IG. And then now we can proceed to calculate the value of IO, because in our formula to calculate T2, we need the value of IO. So IO is basically using the parallel axis theorem is equal to IG plus MD square. Okay, IG plus MD square. IG is 5.625 plus M is 30 and D is basically the distance between G and O. Okay, you refer to what you write here. Okay, we have here IO is equal to IG plus MD square. So D means the distance between O and G. So the distance between O and G is basically half of the length of the rod lah. So basically 0.75. So we will write here 0.75. Do not forget there is a square here. So therefore we will get the value of IO is equal to IO is equal to 22.5 kg meter square. So you got here 22.5 kg meter square. So once we have the value of IO, we can then substitute this in this T2 equation. Okay, so we will get then T2 is equal to 1 over 2 multiplied with 22.5, and omega 2 square is the value that we are looking for. Okay, what we want to calculate is basically omega 2. Okay, so you have here T2 is equal to 11.25. 11.25 omega 2 square. Okay, so now we have the kinetic energy, T1. We have T2 is equal to 11.25 omega 2 square. We have US and we have UW. So basically now we can then write the final equation, which is the principle of work and energy to solve this. So using the principle of work and energy, okay, the principle of work and energy says the initial kinetic energy T1 plus the total work done U is equal to T2. So we will substitute all the values that we know. T1 is equal to 0 plus we have 2 work done here, which is 220.73. That is the first one from UW. And we have minus 160 joule from US. Work done by the spring is equal to 11.25 omega 2 square. And therefore finally we can get the value of omega 2, which is equal to 2.323 radian per second. 2.323 radian per second. Okay, so this is the final answer for this question. All right, any question on this, on how to solve this example problem? Do you have any
yes,
question?
Sir.
Yes.
Yes. Untuk apa origin? How do we get 0.5?
0.5. Okay. 0.5 ni adalah original length of the spring. Maksudnya keadaan spring ketika dia unstretched. Jadi dalam soalan ni ada bagi tahu the spring is unstretched when theta equals to 0. Meaning that pada position yang pertama lah, theta equals to 0 adalah ketika rod ni berada pada kedudukan horizontal straight macam tu. Okay, so spring pada ketika ini adalah unstretched. Inilah panjang spring yang asal, the original length of the spring. Jadi macam mana nak tahu panjang ini berapa? So kita tahu daripada O ke hujung sini adalah 2 meter. Ini adalah diberi dalam soalan. 2 meter is the length from O to the end, to this spring punya hujung lah. And we know the length of the rod, which is 1.5. Dia ada bagi kat sini, length of the rod is 1.5. So bila rod ni pada kedudukan yang pertama, panjang dia masih sama lah, 1.5 lah. So this is 1.5 meter. Jadi bila yang atas ni 2 meter, yang sini adalah 1.5 meter. So we can then calculate the length of the spring pada asalnya adalah 0.5 meter. You just tolak lah 2 meter minus dengan 1.5 meter panjang rod. You understand?
Yes, sir.
Okay. Alright, any more question sebelum saya proceed kepada next example?
No, sir.
No, clear? Okay. So if clear, let's move on to the next example problem, which is question 1811. Okay. So ini pun lebih kurang sama dengan ada example yang kita buat pagi tadi. This is obviously a general plane motion problem. You can see point B is moving to the left translation. Point A is moving downwards translation, and whereas the rod itself is having a rotation lah. Rod tu akan rotate. Okay. So 30 kg rod is released from rest when theta is 45 degrees. So theta 45 degrees ni lebih kurang macam position yang ditunjukkan dalam gambar lah. So let's say this is theta is 45 degrees at this position. So determine the angular velocity of the rod when theta equals to 0. So when theta equals to 0, this angle becomes 0 is when the rod is dah turun horizontal like this lah. And then it says the spring is unstretched when theta is 45 degrees. So masa mula-mula start, the spring is unstretched. Okay. So now what we need is to first draw the position of the position of the spring lah. Okay. So first we draw the initial position. So let's draw a circle like this, like that, and we have like this. So this is the initial position of the rod lah. So this is point A, and this is basically point B. Okay, and at this position, the spring is like this, is unstretched lah. So this is the original length of the spring. And then the second position, where is point A now? Point A has gone down here. Point B has moved somewhere over here. Okay, and this will be the rod like that. And what happened to the spring? The spring is now all over the rod like this. Wait. Okay, the spring is like that. So this is how the the position looks like lah. Okay, so maknanya yang warna hitam ni adalah position yang pertama, initial position. Yang warna biru adalah the final position yang kedua. So this is point B pada position yang kedua. This is point A pada position yang kedua. Okay. Alright. So what we want to determine is angular velocity bila dia dah berada pada kedudukan horizontal. Alright. So let's look at how many work done that we have here. So we have, this is the center of gravity, point G, and at point G we will have mg pointing downwards. Okay, and pada position yang kedua juga, point G will be somewhere here in the middle, and we also have mg pointing downwards. So there will be work done by the weight, because here we have the change of height. Okay, so this will be our delta y lah. Okay, so this will be the delta y. Delta y is going to be negative sebab dia pointing downwards. So this is our delta y, like that. Okay, so later kita kena determine what is the value of delta y. That is one. Okay, so let's look at how we can determine the value of delta y. Okay, so from here we can imagine a triangle like this. We can start from here to here to here. So that is a triangle. Kalau saya boleh zoom in. Okay, then kita boleh extract triangle tu. untuk nampak dengan lebih jelas. So this is our triangle here, like that. And the delta y is here. This length of the triangle is our delta y. Do we know the angle here? Yes, we do. This is 45 degrees. Angle yang diberilah pada mula-mula position yang pertama, 45 degrees. Do we know the hypotenuse of this? Meaning that this is point B. Dekat bucu ni adalah point B. Dekat sini adalah point G, not point A. So what is the length of B to G? This is basically B to G. Point G is somewhere here lah in the middle. Saya guna warna lain supaya nampak. Okay, this point G is somewhere here in the middle. This is point G. So the length B to G is basically half of the length of the rod. So kalau kita zoom in ke sini, B to G punya length will be 0.75. Okay, 0.75 because the total length of the rod is 1.5 meter. Okay. So this is the information that we know. And we also know that this is 90 degrees. And up here is also 45 degrees lah. Okay, this is, we have enough information to get the value of delta y by using the sine rule. So we can use 0.75, okay, divided by sine of 90 degrees. Okay, 0.75 is this side divided by the sine of opposite angle, 90 degrees, is equal to the delta y divided by the sine of its opposite angle, which is sine of 45 degrees lah. Okay, delta y is here divided by the sine of the opposite angle of delta y, which is 45 degrees. So we will have then the value of delta y is equal to 0.5303 meter. That is the value of delta y. So from here we can then calculate UW, which is minus W times delta y, which is equal to minus, what is the weight of this? 30 kg. Okay, so 30 kg. So we have here minus 30 times 9.81. Okay, times, remember delta y now is pointing downwards. So we will have a negative value of delta y lah. So minus 0.5303. Okay, 0.5303. Okay, so therefore the value of UW that we get is UW will be positive 156.08. 156.08 joule. So this is our value for UW. Okay, that is the first work done. Okay, now the second work done, which is the work done by the spring lah. So we can see here the spring is initially unstretched. Okay, pada angle theta equals to 45 degrees. The question says the spring is unstretched. So we know that S1 is equal to 0 lah. So let's write the equation first. US is equal to minus 1 over 2 K S2 square minus S1 square. Okay. So K is given 300 Newton per meter. Dalam figure ni ada tulis. So we know the value of K. Now we need to find what is S1. So S1, it says here, when the theta is 45 degrees, the spring is unstretched. So we know S1 equals to 0. Okay. Now we need to find what is the original length. Okay, jadi kita balik kepada gambar ini. So if I can use the highlighter here, you can see this is the position 1. That, okay, the blue color. So if we extract that, we will get the original length of the spring lah. Okay, we will get the original length of the spring. So let's extract that that triangle. So that triangle is like this, and it goes up here like that. Okay. So dekat mana original length of the spring ni? Original length of the spring is basically down here. This is L original dekat bawah. Okay, you can see here this is the original length of the spring. So kita nak tahu berapa panjang spring ini yang bawah ni. So basically it is the bottom punya length lah. So do we know the hypotenuse of this this triangle here? What is this hypotenuse? The hypotenuse here is basically the length of the rod, which is 1.5 meters. So we actually know this is 1.5 meter. Okay, and then we also have the angle. The angle here is 45 degrees. The angle here is 90 degrees. The angle here is also 45 degrees. So by having all this information, we can use apa nama dia, sine rule to find the original length. So basically L original divided by sine of 45 degrees is equal to 1.5 meter divided by the sine of 90 degrees. Okay, so from here we can get the value of L original ataupun original length of the spring, which is equal to 1.0607. Okay, 1.0607 meter. Okay, this is the original length of the spring. Okay, so now the original length kita dah tahu. Now S1 pun kita dah tahu, which is 0. So what we want now is S2. S2. How do we get S2? Okay, how do we get S2? Pada position yang kedua, length spring punya panjang adalah this. This is the length of the spring pada position yang kedua. But this is not S2. Remember, S2 bukan panjang spring. S2 is the pemanjangan spring. Jadi kita nak kena tahu panjang spring pada position yang kedua, which is this length lah, panjang spring pada ketika ini. And then kita kena tolak dengan original length of the spring. Then only we will get the value of S2. So, anyone can tell me what is the length of the spring pada position yang kedua? This one. Based on this drawing here, what is the length of the spring pada position yang kedua? Anyone? Any idea?
1.5.
1.5, exactly. Panjang spring pada position yang kedua adalah sama panjang dengan panjang rod tu lah, because rod tu dah turun habis horizontal, spring tu memenuhi sepanjang rod tersebut. So panjang spring pada position yang kedua, ataupun kita let's call it as L2 lah. So L2 is equal to 1.5 meter, and therefore S2 is equal to L2 minus L original. Okay, L2 minus L original. So we have here 1.5 minus 1.0607. And therefore we get the value of S2 is equal to 0.4393. Okay, 0.4393 meter. That is our S2. So once we have all this information, kita akan substitute dalam US. Okay, US. So US is basically minus 1/2 multiply with K. What is the value of K here? 300 Newton per meter. Okay, K is 300. And then we have S2 square, which is 0.4393 square minus 0. S1 kita adalah 0. Therefore, we get the value of US is equal to minus 28.95 joule. Minus 28.95 joule. Okay, so now we have the UW, which is 156.08, and we have US minus 28.95. Okay, the next step, same like what we did before. It says release from rest. Okay, so it says released from rest, released from rest. So we know that initial kinetic energy T1 is equal to 0. Okay, so this is our next important information. And then T2, okay, T2, this is what do you call a general plane motion problem. So macam contoh dalam kelas tadi, for general plane motion, we need to find the location of IC. Okay, so now let's see where the location of IC is. Okay, kita kena lukis mula so that you will be clear. Okay, so we have point A here, and then point B straight, and point B is here. This is our position 1. Okay, sekarang tak payah tengok the spring, because now we want to see where is the IC punya location. So this is going to be point A, and this is our straight line, and this will be our point B. Okay, so this is kita akan lukis VA. So VA is pointing downwards pada position yang pertama. Position yang kedua juga VA is pointing downwards. And VB is pointing in this direction. Mana satu B, mana satu A? VA, VB, betul. Okay, so VA is pointing downwards, VB is pointing in this direction. So, untuk kita cari the location of IC, as usual, you need to draw perpendicular line. Perpendicular line adalah 90 darjah line lah daripada VA. So 90 darjah ke sini satu, 90 darjah ke sebelah sini satu. That is one. 90 darjah kepada VA. And then you draw another 90 degrees line to VB. Okay, and what you can see here is that the intersection point is at point B. So basically this is the location of IC lah. Intersection tu berlaku pada point B. So point B is basically the location of IC. Okay, so untuk memudahkan calculation T2, we will use the equation T2 is equal to 1 over 2 IIC omega 2 square. Okay. And in order to calculate IIC, kita perlu calculate IO dahulu. So we need to find IO. So now, IG bukan IO. We need to find IG. IG is basically equal to, this is also a rod, a slender rod. Jadi IG macam biasa 1 over 12 ml square. So we have here 1 over 12, m is 30, L is 1.5 square. Okay, so we have IG is equal to 5.625 kg meter square. Okay, and therefore IIC is equal to IG plus MD square. And what is the value of D here? D is basically distance dari IC ke G. Okay, distance IC ke G is basically the value of D. So, dekat mana pada position yang kedua ni, dekat mana point G? Point G is basically in the middle lah. This is point G. Jadi, D here is basically separuh lah. Separuh daripada panjang rod tersebut. So D in this case is basically distance dari IC ke G, which is separuh daripada panjang rod 0.75. That will be D lah. This is the D. D is equal to 0.75. Okay. So we can then substitute in here. IG is 5.6. Tak muat. Saya tulis kat bawah. Okay, is equal to here 5.625 plus 30 times 0.75 square. All right, so therefore you will get IIC is equal to 22.5. Okay, 22.5 kg meter square. Okay, so we will then substitute this IIC dalam equation T2, so you get 1 over 2 multiply with 22.5 and then omega 2 square. So therefore, we will get T2 is equal to 11.25 omega 2 square. 11.25 omega 2 square. Okay. And the last step adalah to use the principle of work and energy. Okay. The principle of work and energy. Okay, which says that initial kinetic energy T1 plus the total work done is equal to the final kinetic energy T2. Okay, so we know T1 equals to 0. Total work done, kita ada UW 156.08 and we have US, which is negative, minus 28.95 is equal to T2, which is 11.25 omega 2 square. And therefore, we will get the value of omega 2 is equal to omega 2 value is 3.362. Okay, omega 2 3.362 radian per second. Okay, so that will be the final answer for this question. Okay, any question? Any question on the two example ataupun on the on this example for general plane motion? This is basically general plane motion. Contoh yang pertama tadi adalah rotation. So do you have any question? Basically step dia sama je lah. You just need to determine apa ni what forces is doing work. Dalam contoh yang awal dalam kelas pagi tadi, there is no spring. So force yang buat kerja maybe there is a force F ataupun force P yang di-apply kepada objek tersebut, ataupun sometimes you have moment menyebabkan objek to rotate. So that is the force that you need to look at, whether dia buat kerja ataupun tidak. And sometimes there is a change of height kepada point G. You kena tengok point G tu ada perubahan height ataupun tidak. So maksudnya daripada position yang pertama kepada position yang kedua, look at point G, the center of gravity. Dia ada perubahan tak dari segi distance in y axis? Kalau ada, maksudnya dia ada work done by the weight. And then in the a few examples yang terakhir, kita lihat contoh yang melibatkan spring. So bila spring ada stretch ataupun spring ada compression, and there will be work done by the spring. So when it involves spring, you need to be careful about the original length of the spring. Pada keadaan mana spring tu ada original length, sometimes most of the times dia akan kata the spring is unstretched pada sudut theta berapa-berapa. So you need to find what is the original length. Bila spring tu keadaan dia unstretched, that is the apa nama dia, original length of the spring lah. Okay, any question before I think we end the replacement class tonight. So I have shown 2 examples. If there is no question, that will be the end of our first subtopic of chapter 3 lah. On Wednesday, I will see you guys again and we will discuss the next subtopic, which is the impulse and momentum. Any question before we end the class?
No, sir.
Okay, yang lain?
Sure.
Okay, so alright. Kalau tak ada soalan, thank you very much for joining the class. I have recorded this session and I will share in the WhatsApp group as well as I will upload in Kalam dalam bentuk YouTube punya video, so you can watch later. If you have any question, feel free to ask me on Wednesday when we have face-to-face class. Okay, so if there's no question, thank you very much. Good night, guys. I will see you again on Wednesday. Assalamualaikum and have a good night.
Thank you, sir.
Welcome.
Thank you, sir. Thank you, sir.
Welcome.